Good morning. My name is Peter O'Donnell. I'm really excited to have the privilege of being here today. These kinds of things are weird, right? We went a couple of years without them. I get emotional if I talk about it. So it's really great to see people that care about the work that we do, and particularly care about making it safe. To me, security is about safety, and security is a symptom of a high-performing computer system. I got into security because I was a sysadmin. If you were a sysadmin in the 90s, you owned security, right? So I implemented SSH and took Telnet off the boxes. And anybody remember TCP wrappers? Yeah, right? TCP wrappers was like EC2 security groups. I owned a Unix environment on the public internet. We had a Class B at American University, which is amazing in hindsight, and our data center and all the dorms all had public IPs. There were no firewalls. There was no NAT. So it's an interesting environment to grow up in. Before I get into it, really want to say thank you, thank you, thank you. This community means so much, and it means so much to us at Amazon. We really care. And if you've been working with us for a long time, I think you have a sense that we're a different kind of provider. We're a different kind of IT partner, and we're a different kind of people. Our personality is different, the things we care about are different, and what we prioritize is different. And the fact that it resonates with the community makes us better. There is a building in Seattle. All the Amazon-owned buildings have fanciful names. And there's a building in Seattle named Low Flying Hawk, which is a weird name. Why is it named Low Flying Hawk? Low Flying Hawk was the online handle of a very belligerent and mouthy poster in the beginning of the AWS forums. And every time he'd be complaining about things and finding things, and he was frustrating, and he was right a lot. And it made us better. And the story there is incredible because we named a building after the idea of, in Jeff's original words, this idea of a wonderfully dissatisfied customer. That when business is good, we should still be looking for our wonderfully dissatisfied customers. Thank you to John Varghese for putting this whole thing together. The Community Heroes program really means a lot to us. I think there's more than one hero in the room, by the way, and it's very, very cool. These are folks that really stand out, and we have helped amplify them as they have helped amplify us. So thank you, John. It's really cool. Thanks for all the speakers caring enough to put together a talk and put together slides, even if you finished it this morning. Really means a lot. It really means a lot. The Computer History Museum, what an incredible place. One of the tenets of the principles at Amazon is respect what came before. And I was privileged enough, my undergraduate sponsor, my undergrad advisor, Dr. Tim Bergen, was like a maniac for computer history. So early on in my computer career, really was exposed to this idea that like, in order to understand what we have today, you must understand it in this continuum of what is today 70, 90 years of computing. And it really is extraordinary, especially if you've had a chance to reflect on where we came from. I was just kidding with some colleagues outside. Core memory. Core memory is not named core because it's in the middle. It's named that way because there used to be little magnetic cores in, strands of copper, and that is what maintained state. And that's why it's called core memory, which is an absurd idea. And then finally, our customers. I guess if you are here, you're not just an enthusiast, but you very well may be a customer. And we thank you for that. Amazon is very unique, and again, I'm very proud of AWS having this, because I grew up in enterprise IT, and like IT vendors are, and like we begin with the customer and work backwards. And obviously there's a lot of great IT vendors, and there's certainly some here represented today, and this idea of customer obsession powers everything we do. So thank you for being an Amazon Web Services customer. Okay, what's a PMOD? My name is Peter Mortimer O'Donnell. PMOD has been my login name since HoloNet. Anybody from the Bay Area remember HoloNet? Get a couple of chuckles. So I used to dial into an X25 and I had PMOD at holonet.net. in like 92 when I was like 14. So that's who I am. I've been here for 9 years. I was a dedicated SA. I led Capital One for 3.5 years, got them into the cloud, first retail bank system in the cloud. For the last 5 years, I've been a security solutions architect, working with customers like Capital One, but also Airbnb, the people in Cupertino, SAP, and a lot of other great customers. I have a background in not only security, but also storage. Every good Amazonian principal SA should have a couple of services that you're 500 or 600 in, and mine are IAM, KMS, and S3. I was part of the team that drove ubiquitous encryption. When I first came to AWS, you could attach an encrypted EBS volume, but you could not boot from one, which is weird. And none of Kinesis or Dynamo or SNS or SQS supported encryption at all. And there was a lot of us who took up the cause. We drove ubiquitous encryption, and then Werner got on stage in the fall of 2017 and said, this is what we're doing. Everything is always going to support encryption, and it's really great. I'm a former management consultant. That's what I did before I got here, but I have a Unix heart. I have a bachelor's in computer systems, and I'm a COVID survivor. And I realize probably all of us, every person in this room is a COVID survivor, but I did it the hard way. I spent 2 months in the hospital, 2 weeks in a coma. And so coming back from that was a very strange experience. And I think a lot of people, probably at least a handful of people in this room, have had near-death experiences. I don't recommend it, but it makes you excited for being here. The work in this career, in this industry, is the biggest thing to me. And so it's a real privilege to be here. So I'm going to talk about a lot of things today. I am going to talk about AI. First time you've heard of it. It's going to be very exciting. No one's ever spoken to you about it before. But I want to begin with some ideas around what we believe and what we know to be critical to security outcomes. Bezos has this great story where the line is, people ask us all the time, what's coming in the future? What are the big trends? What's going to be new? And at Amazon, we don't necessarily focus on that. And instead, we stay laser focused on the things that are not changing, the things that will always be true. And so yeah, modern stuff is cool, but the things that will never change are absolutely critical. And I put them in red there, which you can't really tell, but patching and vuln management and credential and secret management, if you can solve those, you take off like 2/3 of all your problems. So yeah, you can talk about inventory. You can talk about all the other stuff. You can talk about blockchain if you want to. But if you don't do vuln management and credential management and secrets management, you will have a bad day. Because the way people get popped is not exotic. Now, you might have nation state problems, and you might have threat actors living in your house, and if you do, then whoa. But generally, it's a lot of doorknob rattling. And the doorknob rattling works because they find credentials, not because they find a 0-day, not because they sneak in through the printer system, through the HVAC. No, they find creds. And I swear to God, you must take this seriously. We believe very strongly about getting humans away from data. It's really important to our customers. You should also be doing that. If you own and operate data systems on behalf of other people, if you have a custodial relationship, that means your sysadmin team probably has way too much access to things they should not have. It's just a reality. And you need to be vigilant about that. You need to invest in automation, you need to invest in detection, and you need to get your people away from the data. And they will thank you, right? They will thank you. This means you can stop changing passwords constantly. At Amazon, we stopped changing passwords, by the way, which is crazy. But the truth is, it doesn't matter because we're MFA 100% all the time, everywhere. So I mentioned ubiquitous encryption. This is also something you should invest in. Encryption's a great control. You should use it. Again, if you care about data, you should be looking at field level encryption. Field level encryption comes with a lot of trade-offs. Can't really build an index over an encrypted field, but like get the people away from the data. Cryptography is a really good way to do that. This long drive towards zero trust, again, I was kidding with some colleagues who was like, are you gonna talk about DevSecOps? Are you going to talk about zero trust? Going to talk about blockchain, Kubernetes maybe? And no, the reason I'm really here today is to tell you things hopefully you haven't heard before and get you to think in ways that you hadn't necessarily thought before, or if you have, to reinforce it and validate it. And finally, proactive security, which is what we call AppSec, is super important. Please try to find problems early, right? You can call this shift left, you can call this DevSecOps, you can call it a lot of different things, but please try to find problems early. If security shows up at the end and says no, then everybody has failed in their job. The application developers have failed, the VP of engineering has failed, the VP of security has failed. Security is not an afterthought. Security must be built in at all layers of the stack, all the time, everywhere. And that means proactively looking at, oh boy, you shouldn't shape it that way because that shape is inherently risky. And if you can have that conversation during the whiteboard and not the code review, everybody wins. Everybody wins. And your auditors are going to like this. There's another talk I gave a couple years ago at Reinforce about we all want the same things, about trying to bring together auditors and SREs. And all of this, by the way, has a compliance angle. And if you made a list of the top 10 behaviors of like, what's an effective SRE? Repeatable, measurable, observable, all of that. It's exactly what your auditors want. So, if there's one word I'm going to come back to today, it's rigor. Rigor means being serious. Rigor means not relying on good intentions. Rigor means building mechanisms, which is a very Amazonian thing, to accomplish outcomes and then inspecting those mechanisms over time. Rigor means checking it out. Some random developer at Microsoft, God bless him, noticed that his SSH connections had unusual latency spikes. Rigor. We're going to come back to that. So, Gen AI. Let's do a little bit on Gen AI. For a long time, computers have had the ability to manipulate tabular data. Arithmetic. The first thing we taught the computer to do was how to add, subtract, XOR maybe. And this ability to manipulate numeric data is super powerful. It is the predicate for everything the computer has done since. But we found now new ways to manipulate data that is not just arithmetic anymore. So for a long time, bring up the lights. I'm gonna start sweating. For a long time, we've been able to manipulate numbers. Since forever. ENIAC, manipulating numbers. But now we have this new ability to transform language. And language is not structured like numbers. Well, as it turns out, if you keep pulling the onion, it might be. But language and the manipulation of it, the transformation of it, unlocks a lot of big ideas. Number one, the purpose of the system could be to manipulate language. Summarize this content. Help me understand the tone or the sentiment of this content. It could be to build a magic talking computer. Explain to me the virtues of AWS Snowball in the style of Tolkien was one of the first things I ever asked you-know-who's chatbot. And sure enough, it did it. It's kind of wild. But one of the most important things that I think we're particularly excited about is exposing existing computer capabilities with brand new user interfaces and user experiences. So yes, transforming language, amazing. Analyzing language, amazing. Magic chatbot, Oracle thing, amazing. But what's really, we think, going to be critical is the ability to use natural language to tell the computer what to do. If you've worked in user experience, you know this phrase, divination of intent. How can the computer figure out what it is you're trying to do? Mind reading, we're getting there. We're not getting there. That Nazi with the implant thing is not how we're gonna get there. But the important part is that we do have this ability to now ask the computer to do things in natural language. And so we're bringing this capability to more and more services. So this is one of the most important things I want you to take away from this part of the talk. Who here has ever heard of prompt injection, right? We all have. This is just input validation. The punchline that I'm going to build to here is that all of these problems, security, privacy concerns with Gen AI, they're all familiar to you. They're all the same monsters in a different coat. Insecure output handling, right? What do you do with the data? Has always been a problem. Training data poisoning. We've talked about garbage in, garbage out for, longer than I've been alive. Model denial of service. Of course you can overwhelm a computer system by sending nuisance traffic. It's like one of the oldest problems that we have in computer security. Supply chain vulnerabilities. Yeah. If you try to disinfect your chef's salad by spraying it with chlorine, you will have ruined the experience. This is what endpoint agents do, basically, by the way. But if you really care about the health and safety of the salad, you know where you get your tomatoes from. You know the provenance of those eggs. And if you really care about the safety of the salad, you really care about the supply chain. And again, not a new problem, not a new shape of a problem. Sensitive information disclosure, that's kind of at the heart of information security. Information security, of course, has three legs: confidentiality, integrity, and availability, but most of what we do is the confidentiality part. And of course, that's the core problem. Insecure plugin design, that's a little more esoteric, that one's interesting. But again, no kidding. The computer modules you glue together need to all work right? Yes, of course they do. Excessive agency, now this one's weird. Excessive agency, what this really means is an overpowered computer system. That the computer system can and might do things you did not intend it to do. That is a relatively new problem. For years, we've only had deterministic systems, where through either formal methods or really strong fuzzing or really strong unit tests, you could explore the full range of what you could possibly get the computer to do. As it turns out, that might not be true anymore, and that requires more flexible thinking. Over-reliance, again, like classical problem in warfare. There's a lot of issues with GPS in certain parts of the world right now. If you over-rely on an untrusted computer system, you're gonna have a very affected outcome as a result. And finally, model theft. Yeah, no kidding, don't let people walk off with your stuff, right? Like, that's always been true. It's always been true. So this is very fancy. I'm not gonna drain this, but this is like kind of a realm, an overview of what we're talking about. I'm not gonna walk through this. But if you've never seen a diagram like this before and you care about this topic, you need to go find diagrams like this and learn them. The full end-to-end state of a computer system and how it behaves and what its inputs are has always been fundamental to computer security. But again, now that we've introduced some non-deterministic qualities to the system, things can and will get weird. So we have a stack here. We've been telling this three-layer story for 7 or 8 years, ever since we started to build the classification AI systems at AWS. Textract, recognition, comprehend, right? Call and response APIs. Here's some data, what do you think about it? Here's some data, could you annotate it for me? Recognition annotates, or at least it returns range boxes and tells you what's in it. So if you send it a vacation picture, it'll say, child, adult, smiling, that's a surfboard, that's a bicycle. And that's incredible. Computer vision is a really big idea. But that's a very high order concept. And at the bottom level, of course, we sell a bunch of hardware, and our friends at Intel sell a bunch of fancy hardware. And if you want to roll your own, we can give you just the gear. P5s, God bless. P5s, by the way, support 3,200 gigabits per second bidirectional. Isn't that weird? 3,200 gigabits. And finally, in the middle is really the interesting part, right? Where we have built semi-abstracted services for our customers. And the security of all of these things is critically important. What's interesting is that we kind of do the security of the top one and the bottom one, but in the middle, you do a lot of security. And so you need to richly understand how these systems work, how they come together. Lots of great stuff online from us about how to secure and reason about each of these 3 layers of the stack. And with each of these layers of the stack comes with some classes of concern, right? And so as you reason about what is this computer system's purpose, do a threat model. Is anybody in here not done threat modeling, right? Learn threat modeling. Know why the phrase entry point matters so much. There is a room here today named for von Neumann. I'm a von Neumann guy, right? There's input, there's operations, and then there's output. Find all of the inputs of your computer system and understand them. And years ago, a mentor taught me that the name of the game is really simple. The name of the game is what could go wrong. That's the business that we're in, is what could go wrong. It makes us anxious, but it's really worth thinking that way. There are some classical risks associated with each of these layers. And again, like reasoning about this, not in the abstract. In other words, don't begin with, how do we secure Gen AI? Don't begin there. You can't begin there. But what you can do is reason about precision risk based on your deep understanding of the nature of the system and playing, again, what could go wrong. At each of these levels, or layers anyway, what could go wrong? Have I accounted for the full range of responsibilities for looking after this part of the computer system? That is your challenge. And it's not only your challenge to do these things, it's your challenge to articulate them to others, to stakeholders, to your boss, to procurement, to whomever's writing the checks. You have to help them understand what problem you're solving, how you intend to solve it, the outcomes you expect to achieve, and the process by which you will achieve those outcomes. And again, if there's one word, rigor. Finally, the bottom layer, again, garbage in, garbage out. Really need to understand the full flow of computer systems. I gave a talk at reInvent just this past fall, and what's really interesting is that you have and may already have data security problems that you don't know about. And it's not from vulnerabilities, it's because you've polluted data sets. One of my favorite stories is working with a large customer. They told me this story. They were very excited. We got rid of social security number, taxpayer ID. We got rid of it in our call center. We no longer look people up that way. We took the field out of the system, right? So like when the call comes in, little system pops up. Who are you? I'm Priya Smith. What's going on? Here's everything about me. What happened is that all the call center agents put the social security number into the comments field. And then, if you take that and you glom it into the chat transcript, all of a sudden, you have polluted your long-term data lake with taxpayer ID. That has a security risk for sure, but it absolutely has a compliance risk. And this happens in lots of places. SNS, log spills. I'm moving data around between systems. I'm using queues and messaging buses to do it. But if something spills into it, all of a sudden your log system is in scope for GDPR. And you never knew, you never thought about that. Why would it be? There's not supposed to be anything like that in there. Well, surprise, there might be. And so the pattern we end up seeing is building systems to have a pipeline. And this is another important part of where AI can be super useful, is that if you build a system with something like Amazon Comprehend, and there's some built-in stuff to SNS and CloudWatch, where it can find this data for you. It can automatically, SNS, if you have an SNS message topic, and you're using it to glue computer systems together, you can put a security policy on it, and SNS itself will discover if you've got social security numbers on your messaging bus. Hopefully you don't, but you might. If the wrong developer turns on the wrong level of logging, all of a sudden you've got PII flowing into your Splunk. And again, if you had begun with just the whiteboard, and begun just trying to understand where do we expect data for compliance and regulatory reasons, where do we expect it to be? You don't expect it there, and you might not build a system to detect it. So thinking more broadly, thinking with rigor, is critical to understanding the full realm here. I want to talk about this, responsible. As computer scientists, there is a lot of ethics to what we do. And all of the classical sciences have already had their horror movie moment. Physics has weapons, chemistry had weapons, medicine, a lot of ethical, ugly things can come from medicine, but our business is only just now getting to the uh-oh horror moment. We have a responsibility as security professionals to not only seek the security of the computer systems for which we are tasked, but also to hold a bar for how the system is built, why it is built, and the characteristics of it. I grew up at Fannie Mae, and we knew this problem 20 years ago because we had a system that underwrote mortgages. And we had a very serious internal reflection on, hey, is our underwriting system, is it a memorialization of systemic racism? Shit, it might be. And when you build these systems, when you develop a computer model based on inputs, there are so many opportunities to make responsible, ethical choices. These are kind of how we think of it, but it's really, really important as professionals, as humans, to bring responsibility to the craft of what we do. We've got a lot of good resources online. This is a good transition slide. So QR code, but really just search online. Okay, I'm gonna pivot now. Next part of the talk. People love to hear about the stories of Amazon. Tell me about what's happening behind the curtain. How do you do your thing? How is it that you have built all this? There must be some secret sauce. And I'm here today, and I have the opportunity to share with you some secrets about what we do here at AWS. And there is a secret ingredient. But surprise, it's not what you think. Our secret ingredient is our culture. Rigorous, obsessive ownership. I grew up with a Unix head. I built my career at being a Unix head, and the Unix philosophy of do one thing and do it well, and the old Richie Ken Thompson videos from the 70s talking about the nature of Unix and why it was different than operating systems that had come before. That's kind of what we did at AWS. AWS is just like 21st century Unix in a whole miasma of APIs. But this is the secret ingredient, that we are deadly serious about what we do. And I tell this to you for two reasons. Number one, I think it's important if you are working with us, if you advocate for us, if you tell your peers and your colleagues that you really like AWS, you should know why. And this is why you really like us. Because we have rigorous, obsessive ownership across everything we do. So let's talk about what culture really means. What is the purpose of culture? And this is the answer. And this is a weird phrase. The purpose of culture is to eliminate renegotiation. Here in the West, were you to climb these stairs, were we to suddenly have to evacuate, you would stay to the right. And you just know that. That's what we do here in the West. And if you visit Tokyo and you go to the Tokyo subway, which is an amazing phenomenon, by the way, the Tokyo subway, you stay to the left. The stairs work differently there. And it would be insane were you to try to negotiate. No, we should do it differently. Nope. Culture is what you do. Culture is how you behave. Culture is a set of expectations that you can have of other people, that other people will have of you. And perhaps most importantly, culture is expectations that you can have of yourself. That this is the behavior. This is our custom. This is what we do. And so we do a lot to communicate to customers about the culture of security. What is security culture? I don't know how many CISOs I've spoken to about like, help me build a culture of security, and we really want to do that, but it requires deep, rigorous ownership. But this is the purpose of culture, so let's talk about some of the dynamics of culture. If there's one word, it's ownership. Again, rigor. And there's a virtuous cycle to be built here. That caring, really giving a shit, makes a big difference. And your colleagues, and if you're leaders, modeling this behavior will cause the people around you to do better work. It's amazing. If you've ever been a tennis player or a golf player, or really probably any sport, if you're playing against a better opponent, perhaps ironically, you do better. And if you're surrounded by schmucks who are not doing a good job, it affects your behavior. So this culture has to be reinforcing. It has to accrue and accrete virtue. And what is virtue in this context? Well, the primary virtue is avoiding bad days. Right? Again, security being a symptom of a high-performing computer system. But this rigorous ownership and how we can move quickly at Amazon, like the famous Log4j incident. Who had the Log4j problem months later, right? A lot of people all had Log4j problems, like all the way into the spring and maybe that following summer. And when you're us, and you've got businesses betting your business on us, we had to move quickly. But the good news is we had this muscle. But you need to develop this muscle over time. And like developing any muscle, it does not happen quickly. And it requires rigor and cultivation over time. This idea of eliminating renegotiation is really, really powerful. It's by establishing norms, normative behavior. How is it that we operate? That is the soul of culture. One thing you absolutely must not do, especially in the context of I find myself avoiding these slides. I'm going to go over here for a little bit. One thing you cannot do is negotiate under duress. Do the run books and have the call sheet during the day over a nice lunch. If you get paged at 2 a.m. and then you try to have a conversation about what to do next, you will not succeed, and people will resign angrily and leave you nasty comments on Glassdoor. Do these things when they are easy to do. I'm a Taoist, it's a great Taoist philosophy. Do work while work is easy. Do work while work is easy. Establish these behaviors before you need them. Establish the culture of no blame. See something, say something, raise your hand. Establish that now before everybody is upset and tired and on the phone in the middle of the night. I worked with a pretty big customer, Fortune 100, and they had a thing that was like, we don't get off the call until we do RCA, which is an insane thing to do. And I don't know, has anybody ever heard of that, right? We don't get off the call until we find the root cause. That's insane, please never do that. But you have to understand the dynamics and the incentives that your culture creates. In that example, it creates a rush to root cause. That's not how you get to root cause. You certainly cannot rush it. Let's talk about another secret of our sauce. I think everybody here has heard of EC2 Nitro, right? No? Yes? Cool, all right. So I was at dinner in, I want to say 2016, maybe 2017. It's in January, and this was at our SKO. And we were all a little tipsy. And a manager leaned over to me and goes, the next generation of our hypervisor is going to run on ARM. And if you know the traditional hypervisor stack, how could it possibly be that the hypervisor runs on ARM if the guest is x86? And the answer is, we changed the shape of it. We tore apart the hypervisor. And we moved 3 really big chunks of it out of the main board of the computer. When I first got to Amazon and I first started thinking about AWS, I don't know, 12, 15 years ago, this idea of a computer number, a base 2 number. And I was looking at, like, I think back then, like the largest computers were 8XLs, if you can believe it. And the quantity of RAM was 244 gig. Why is the RAM 244 gig? It's not a computer number. How could it possibly be that that's the size of the guest? Well, because as it turns out, it gets the whole board at the time, the whole droplet. But why 244? Because 12 gig was for the hypervisor. 12 gig of RAM. 12 gig of expensive RAM, I might add. And so we built the EC2 system, and we re-engineered and rethought what it means to deliver this. Now, this has a bunch of great benefits for customers, has a bunch of great benefits for us, and it implies a security posture to the underlying compute construct that all of our services benefit from. That all of our services benefit from. I've often likened the traditional hypervisor model, if you're familiar with it, this idea of DOM0. DOM0 is the base instance of the operating system. I refer to it as a basement apartment. And if you can get into the basement apartment, you very well could look up and see your neighbors. You might be able to dump RAM. You might be able to trace processes. Those are extremely privileged operations. That's true for anybody. It's extremely true if you're a services provider. So when we built Nitro, we didn't build the button. There is no dump RAM button. There is no way for an AWS operator to intrude on an EC2 workload. This, again, has enormous customer benefits, enormous security assurance benefits, and what it really means is that the system itself has better performance characteristics. It is faster because of the result of the Nitro system. Another interesting secret sauce example, Firecracker. Early on, when we started Lambda, the compute fabric below Lambda was regular EC2 instances. And if you remember Lambda cold starts really being a bummer for like the first 5 years of Lambda, that was because if it was truly cold, you didn't have an EC2 instance at all, and we had to fetch one from the warm pool, dedicate it to your account, and then light up the function on it. And because we couldn't just do run instances, because that would come with a latency penalty in thousands of milliseconds, we had to keep a warm pool. And because we care about security so much, we were never oversubscribing CPUs in Lambda. Because if you've got containers sharing cores, lots of bad things can happen, as we well know. And this was years before Spectre and Meltdown when we made these architectural decisions. But what it meant was, Lambda was very expensive for us to operate for a long time. And now we innovated and invented a new way of delivering virtual machines to bare metal. And that's Firecracker. And if you're a nerd and you care about operating system internals and you've not looked at this thing, you should. It's amazing. Like if you're a car person, it's cool to read Car and Driver. If you're an OS nerd, you should learn about Firecracker. Really, really interesting stuff. It's a way of having micro VMs that launch within milliseconds and then can go away just as quickly. And because we don't use containers as a security boundary, we get real hypervisor containment for workloads between customers, between us and customers. So Firecracker is an amazing aspect of our secret sauce for things like Lambda and things like Fargate. Another really interesting innovation. Does anyone remember Heartbleed? Right? Man, that was exciting. What we discovered with Heartbleed is that we, and a lot of people, were relying on some good software, but that was like a little overgrown and crufty. More than 100,000 lines of implementation in OpenSSL for a TLS negotiation. And so we have a very smart engineer named Colm McCarthy, one of our distinguished engineers, and Colm was like, you know what we should do? We should re-implement TLS. And we created S2N. S2N powers the entire S3 front end. It's really remarkable. And I don't know if you can readily imagine how big the S3 front end is, but whatever you have in your mind, multiply it by like 3 orders of magnitude. And so S2N is a re-implementation of this. And this is another example of some of the secret sauce that we have. And again, that comes down to rigorous obsessive ownership. When Heartbleed happened, we realized, oh, wow. A, we're super dependent on something that has some issues in the macro. B, if we go back to first principles, there might be a better way to implement it in the first place. And that's what S2N is. So if you care about TLS and you care about application protocol negotiation, this is a really cool thing to learn about. KMS HSMs. KMS HSMs are also secret sauce for us. These are bespoke. We are in our, I don't think I'm supposed to disclose it, but we've had more than a dozen generations of these HSMs. And indeed, in 2022, going into 2023, we changed the entire fleet. No downtime, no service events, but we replaced every single HSM in every single region, every single commercial region. And now you've got new hardware for the HSMs, and they are better, faster, and stronger. And for the first time, they're validated at the 140-3. That's the new program for FIPS validation. And in terms of crypto module, our entire pizza box is the crypto module these days. It's no longer just a little widget on the board. It's the whole box, which is how you get to level 3. And really great innovation on behalf of our customers. Out of the box, we have been able to raise the request per second quota for KMS into tens of thousands by default, available to you right away. The idea that you can get fractional ownership of a virtual machine is pretty cool. The idea that you can get fractional ownership of a fleet of world-class FIPS validated HSMs is amazing. And again, we really care about ubiquitous encryption, and you should too, and KMS is the right primitive to build on. Okay, who wants to hear me talk about post-quantum cryptography? Because I can otherwise skip this part. Does anybody care about post-quantum cryptography? 2 of you. All right, then I'm not going to do it. Here's the short version. Cryptography, the whole idea is predicated on problems that are hard. And they're so hard that the only way to solve the problem is with the key. And if you don't have the key, you can't solve the problem. That's how cryptography works. Is what? The question is, they recently said quantum is broken. So I think that's what I'm talking about, is this idea of, if it even comes to pass, which is uncertain, that a sufficiently powerful quantum computer comes into existence, which is, again, not a sure thing, that were a sufficiently powerful quantum computer to come into existence, there are algorithms that are well known and well understood today that have been around for 30 plus years, that if you use one of those algorithms on a computer that had qubits, that it stops making certain hard problems hard. And certain hard problems that cryptography is based on become easy. And that might be what you're referring to. That's this whole idea of post-quantum algorithms. Algorithms that are predicated on hard problems that do not become suddenly easier with the existence of a quantum computer. That's what's going on. So for like the last 10 years, the cryptography community has been working on this. There's been a bake-off. We expect NIST, the American National Institute of Standards and Technology, to announce the finalists, or not the finalists, the winner, I guess, the final algorithms, and then we will begin implementing them over time. Unless you have crazy nation state problems, you probably don't need to do this any faster than we will. Unless you implement your own cryptography as part of your own product, like if you're in the signing business, then you need to address it sooner rather than later. But if you just get your cryptography from people like us or commercial vendors like TLS and at-rest encryption, don't worry about it, we're on it. The industry's on it. It's all gonna happen, you'll be fine. So there you go, 30 seconds on post-quantum. Skip through this. How is AWS preparing? Okay, another aspect of secret sauce. AWS SIG v4. You do this every day and you do not know it. Has anyone ever thought hard about how access keys and secret keys are used to form authenticated requests to AWS? Anybody know SIG v4? So this happens every day on the order of billions per second, which is such a weird number. And it, baked into it, has a bunch of great characteristics. This happens every day. By the design of the system, it resists man in the middle. By the design of the system, it is scoped to a single region, to a single service. That is to say, the signature and the cryptograms that are associated with that signature are not usable for any other region or any other service. And it's designed to be hyper-scaled performant. 1,000 million requests per second is a weird number, and SIG-v4 is at the heart of that. So if you're a cryptography nerd, if you're an authentication nerd, if you're an AWS nerd, learn about this. It's really, really cool. It's extremely powerful. And once you kind of see it, it's really simple. It's hash, input to hash, input to hash. Like, it's not exotic. But it is a testament to the quality of the original design. SIG-v4's been around for a very long time, long before we were doing billions per second. This is where you can learn more. This is from Cole McCarthy, again, one of our DEs. Really cool deep dive into SIG-v4. Least privilege. This is important. Unfortunately, the truth is least privilege is maximum effort. But you should be caring about least privilege. This is an unseen example that you are using every day. How does EC2 gain authorization to use your key in KMS, to use the key that protects your volume, to attach the block device to the computer? How does that work? You may have never looked at it. That's okay. We looked at it because we designed it. And what we did here is that when we authorize EC2 to use the key material on your behalf, we're not authorizing all of EC2. We're authorizing just the part of EC2 that is your particular instance. That's the 63-bit instance ID. And the constraint here, this is an interesting implementation of what's called additional authenticated data, what we call encryption context. It's kind of like a tamper-proof seal. Not only is the use of the key scoped to that one special service principal that's scoped to your one computer, it's also scoped to that one volume. So the only way for EC2 to make use of your top key in KMS is from that one computer for that one volume. We designed it this way because we could. We talk about this phrase, the security ratchet. The security ratchet only turns in one direction. And we continuously look for opportunities to see if we can get another click. And this is a good example of where we got another click, about least permissions, narrowly scoped. So I want to wrap up. I think I'm doing okay, right? I've got like 5 minutes to wrap. So my call to action is I want you to go be an obsessed owner. I've talked about our culture. It's really good. I think you might find it useful. If you are a security professional, and I assume you are in one dimension or another, be an obsessed owner. Really care. Take rigor into the work that you do and bring craft to the work that you do. There's a lot of people in IT that are winging it. I mean, I'm winging it. But I try to bring craft and care to the work that I do. The same way that a woodworker might care about what she makes. Like, care about the work that you do. It will not only lead to better outcomes, it will also improve the work of the people around you. And dare I say, it will net improve your own satisfaction in the work that you do. Build care and craft and rigor into what you do. Lastly there, the call to action here is that I kind of want what you've heard here today, if it resonates with you, this idea of ownership, this idea of rigor, this idea of culture. If it resonates with you, go give this talk. I'm channeling a lot of other people that came before me. Go channel this talk. Go reach out to your team, reach out to your skip level. Cultivate a stronger and better culture. And it takes time and it takes diligence, but I assure you, it leads to better outcomes, and not just better safety and better security. The role that we have is to enable the business to do its thing. Our mission is not security. Our mission is to let the business do its thing as fast as it can in a manner that is safe. It's a little reductive, but I do love the line, the reason the car has brakes is not to slow it down. The reason the car has brakes is so it can go fast. Because you would never go fast if you didn't have brakes. And that's our role, is to bring safety to the mission of moving very quickly. It is not our job to say no. It is our job to figure out how to say yes in a manner that is safe and sustainable. Real quick, 5 whys, another aspect of culture. Always ask why and never be satisfied until you get to the true root cause. I mentioned earlier the customer that wouldn't get off the phone until they found a root cause, but that means they might have stopped at the first or second why. This is yet another characteristic of rigor. Do the work. Dive deep to understand the true problem. That is the soul of what we do. We are helping keep the internet safer as a community. We are helping keep each other safer as a community. Our lives are so intertwined with technology, and this whole building is a testament to it, that our responsibility is to drive safety and rigor into what we do, and this is a really, really simple intellectual framework to make sure that you get there. It's to always keep asking why. Finally, what's not new? I led at the beginning. A lot of people want to talk to us about what we see that's brand new, what's coming. But we, again, stay laser focused on what's not changing. The well-architected principles, the in-order description of what it means to be well-architected on the cloud is the same today as it was when I got here. It's the same today as when the first time we wrote it down. If anything, we added a couple. We added sustainability, we added operational excellence. But the original 4 are in order, and that's exactly our charter, is to be secure, available, performance efficient, and cost optimized. And if you can do those things in that order, then you're doing really well. And if you're not doing those things, or if you have them out of order, you're gonna have bad days. And we don't want that, you don't want that, your boss doesn't want that, your family doesn't want that either. Like, have good days. Approach it with rigor and deliberate intention. Hope to see you in Philadelphia. We're really excited about this. You can hear more great talks. I'm gonna be there. I'm hosting a panel discussion, which is not that exciting, but it's gonna be very cool. If you're a cryptography nerd, we recently hired a matched set of 3 cryptographers who have worked together for like 30 years, and they move as a unit, and they're like a little squad, and now they work for us. It's very exciting. A couple of them just won awards for papers they wrote in the 80s, because cryptography takes forever. And it's gonna be a great discussion. There's gonna be a lot of really good content. So thank you for this opportunity to speak with you. I hope you learned something today. I hope you got something you can take home. But again, if you have one word, it's rigor. And at all times, we think about leadership principles at Amazon. I have my own leadership principles for the field, and I offer them to you. Be confident, be optimistic, and be empathetic. Thank you so much.